Welcome to my YouTube channel. If you're here for the very first time, please do not forget to subscribe, because every day we upload new videos, new lessons, new things. Mathematics was meant not to be read, it was meant to be solved. Let's solve mathematics together. Where not clear, please do not forget to ask in the comment box there, and we'll be able to clarify for you. Enjoy the lesson. Our teaching platform. This is Mr. Mlonga, aka the teacher. My pupils calls me the teacher. We are here to do mathematics indeed. Be ready for the lesson that is coming forth. If you are new to this channel, you are welcome. Please subscribe so that every time we post a video, you are the first to be notified. We'll be posting videos every day. We'll integrate this function. After integrating this function, then the answer that we get, will differentiate that answer and see what happens. So here we go. We'll start by integration. In a situation where you are given a function y is equal to ax to the power n, then if you have to integrate this one, it means that the integral of y with respect to x is now going to be equal to, this a will be maintained the way it is. You have a over n plus 1, then x n plus 1 plus c plus c. This is the formula we use for integration, where a is the coefficient of x, n is the power of x, and then c is just some constant number which we do not know. It can be anything. So to integrate this now with respect to x, we have y is equal to 3x to the power 3 plus 2x to the power 2 plus 4x. The power there is not seen. When the power is not seen, it means that the power is actually 1. So in place of this blank space, we'll write a 1. Then plus 2. This 2 has no x. So we can write x to the power 0. It will not change anything. This is because any variable or any number to the power 0 is actually equal to 1. So this does not change a thing. Now, let us integrate. To integrate this now, our y is this one. So the integral of y with respect to x in this case, for the first term, 3 over n plus 1. Our n is actually 3. So over 3 plus 1. Then x n plus 1, which is 3 plus 1. This term has been integrated up to that level. Then plus, we go to the second term. There, our n is 2. So we are going to have this constant 2, which is our a. So 2 over 2 plus 1. Then x to the power n plus 1, which is 2 plus 1, plus our coefficient there is 4. So we say 4 over n plus 1, that is 1 plus 1. Then x 1 plus 1 plus. What about here? What do we have there? What do we have here? Our n is 0. Our n is 0. So what do we have? We have a 2 over 0 plus 1. Then x to the power 0 plus 1, like that. From there, we can now continue. We say this will give us a 4. So 3 over 4. Then x to the power 4 plus 2 over 3. That is a 2 over 3 plus x to the power 3 plus 4 over 2. Then x to the power 2 plus, this is a 1. So that is 2 over 1, then x to the power 1, like that. After doing that, we can say this will now be equal to 3 over 4, x to the power 4. This will not change in any way, it will still be the same. So plus 2 over 3 x to the power 3. Even this one has reached its final stage. Plus 2 there, 1. 2 there, 2. So we have a 2x to the power 2 plus this is just a 2, then x, we ignore the power 1, like that. At this point, we have integrated. When you reach the final stage of integration, let me just say you add plus c, like that. So this is the answer we get when we integrate this y with respect to x. That is the answer we get. Our focus is to see the relationship between differentiation and integration. So what we have done is actually integration. Now let us differentiate this with respect to x. If we have to differentiate this with respect to x, let us move in this direction. To differentiate this with respect to x, actually, when you are given a function y is equal to ax to the power n, then it means that your dy over dx is going to be equal to this n will multiply the a, so it will be a n x to the power n minus 1. That is the formula we use for differentiation. So we are going to differentiate these terms with respect to x. The first term, what we have, the power there is 4. Okay? The power is 4, meaning that when we say dy over dx, the power, I said the n must multiply the coefficient. So it will be 4 times 3 over 4. I'm sure the 4s are going to cancel. So we have 4 times 3 over 4, then x to the power 4 minus 1. That is for the first term. For the second term, we have the power is 3. So the power must drop to the left and multiply the coefficient of x. So we have plus 3 times, this is a 2 over 3 times 2 over 3 x to the power 3 minus 1. We are subtracting 1 on the power. Then we come to this one. We get to this one. This is 2x squared. We are saying plus the square, the 2. It means 2 times 2 x to the power 2 minus 1. 2 minus 1. Then this one here, the power is actually 1. So it will just be 1 times 2 x to the power 1 minus 1. So plus 1 times 2 x to the power 1 minus 1. The constant c, when you are differentiating, you actually ignore the constant. You ignore the constant c. It becomes a 0. So then this is going to give us 4, and 4 will cancel. So the coefficient becomes 3. Then x 4 minus 1 is 3. Plus 3 will go with that 3. The coefficient becomes 2. So we have a 2 x to the power 2. 2 times 2 is 4. 4 x, 1 subtracted from 2, the power becomes 1. So power 1. Then plus 1 times 2, that is a 2. Then x to the power 0, 1 minus 1. From that point, we have 3x to the power 3 plus 2x to the power 2 plus 4x. You ignore the power 1, so just write a 4x. Then there, at this point here, x to the power 0, I said any number or any variable to the power 0 is equal to 1. Meaning that in position of x to the power 0, we are going to have 1. And this gives us 2 times 1, which will just be a 2. So this is plus 2, like that. This is going to be our final answer when we differentiate. Now let us see the relationship. We integrated this function to get this answer. After getting this answer, we differentiated this answer to get this answer. Look at the relationship between this and that. 3x to the power 3, this one here, is the same as that. 2x squared is not different from this. 4x is the same as that. 2 is this same 2. This same 2. They are the same. They are not different. So it means that when you integrate a certain function, you can actually differentiate the answer that you get back to the function that you integrated. This also means that when you differentiate a certain function, you can integrate the answer that you get back to the function that you differentiated. This is the meaning. Therefore, we can conclude to say integration and differentiation are two opposite mathematical operations. That is the point. This marks the end of our lesson. Please, if you have not subscribed, this is the time to do so, because every day we'll be posting videos, and it's important that every time we post a video, you are the first to be notified. Where you need to comment, you need to ask something, do not hesitate. We value your support, we value your contribution, be it positive or negative. Welcome once more, and thank you very much for having watched the video. Please share the video with others. Let other lovers of mathematics enjoy the mathematics that we are doing on this platform. It's mathematics all the way until Jesus Christ comes. Thank you very much for having watched our video. Please do not forget to subscribe. Share the videos with whoever is interested in mathematics. Mathematics must be shared. Everyone needs mathematics in life. Please be checking on this channel, because every day we'll be posting new videos, new things, new lessons. Thank you very much once more.